use this microphone. I'm sorry, this microphone. This will pick up your voice. So, explain what you did and what you found out. Okay, the point is to show, so we can all learn from it, because we're going to do the same thing again. Okay? You know which one is yours, right?
Yeah.
So you can take 3 or 4 minutes up to 8 or 10 minutes. Okay? Depends on how much you want to say. More of the volume? Oh. Don't worry about it. It's not a big deal. Just give us a hint. Okay, it doesn't matter. Have that much to say. How can we make this better?
Okay, this is my report. I chose Philadelphia hotel occupancy rate, and I mostly use 8 sheet of the Excel, which is daily data, and I used it with Weka. First, before using Weka program, I predicted myself that how will this going to be, have some kind of frequency. And on here, I expected that there will be less in Sunday and much more in Friday and Saturday. Mostly it comes right, but there was some irregular days. I'm going to show it later. And in this picture, this is print screen of the Weka program. From this, I found out how the occupancy rates comes, and from minimum to maximum rate, and mean means average rate of the occupancy. And this is, in fact, I'm not quite well used the Weka program, so I use mostly to make tables to use in the Excel program, the pivot tables. I use it, and this is what I come from. You can see in Tuesday and Wednesday in Philadelphia, I don't know why, but Tuesday and Wednesday mostly has quite second and third highest occupancy rates, same as demand and supply. Supply is just means the room of the hotel, so it doesn't change much. And demand to supply means the occupancy. So these 4 comes same as what I expected and same as result. And this one, actually, I tried many steps to find out how to predict the hotel occupancy with Weka program, but when I searched some information about this data mining, there is some kind of tabs called predicting, and I wanted to find that some kind of program which has that can predict the future data by data past, but Weka doesn't has it. So I just proved it that the data on the Excel file is actually has big relationship to determine this occupancy rate. That's just what I found. And this is the table above is just about days a week, means Monday to Sunday, but this is what monthly occupancy rate. So I like this results much more better than above one. I found that Philadelphia has high occupancy rate, means high occupancy rate for hotel on June, but I found that this also has some problems or weaknesses. There might be, this is only a rate of 2013 and it doesn't have any before data, so there might be some kind of events in 2013 in around June that it definitely can increase the inviters. I hope there's much more data about Philadelphian official days off or some kind of what actually happened of those certain years. But
Can I stop you for a second? Can anybody think of any way to figure out, to find out, whether that 2013 was an unusual year or not an unusual year? Anybody have any ideas about that? Well, he was just saying that he's not sure if that pattern that he saw here is real or not. If it's that's supposed to be true for every year, but he only tested it for 2013. So is there any way to verify that it's not just 2013?
if there is data.
Okay, so was there data prior to 2013?
Data was from 2008 to 2013, but this occupancy rate was certainly right of the occupancy rate was just 2013, so I cannot make 2008 to 2012.
Okay, so we're missing. So is there any way to do that? Anybody have any ideas?
You calculated the average of occupancy rates as each month in each year.
Yeah, but he said there's only 213, no?
Yeah, each year there is, but I cannot make sure this from year 2008 to 2012 to this certain data, certain tools. I cannot make sure those data, how to calculate and make this data as certain results.
Oh, what I forget, is there data on 2012, 2011, 2010?
It's just monthly.
What?
Monthly, your data monthly from
Just
2008
monthly, not
January.
daily?
It's one daily data.
Okay, all right. Anyway, maybe we can fix that. Okay, any other ideas? That was, of course, that's natural, right? Calculate the average each month, and then you can see the pattern per month. Right. Anything else? Well, we could try to use Google. You can use Google, and you can search within a certain date range, and you could see if any. I don't know. You might be able to identify some events that way, and see if there's anything strange happening. Yeah. There used to be a way in Google to search in the news, just the news part, and you could look for news in a certain date range, like July of 2013, and you could look at the news, but you can't search in Google News like that anymore, I don't think. But go ahead, sorry.
I just make some misunderstandings. This data, the data that I gave was about the whole hotel occupancy rate. those kinds of events are usually is somewhere it's more locational events. If there is not some kind of World Cups or Olympics, that might can affect whole countries' hotel occupancy. But this kind of what I mentioned events are mostly should I say just one place effect. So I cannot make how to gather those whole many information.
Okay, go ahead.
Okay, that's enough for this. And there are other data about the information about the hotel occupancy. I got this from the maybe tab 3 or same tab 8. Those kinds of tables cannot be read by a wake-up program, so I just switched these rows and columns to this and deleted this and used just this part for the wake-up. And it seems quite has high errors, but
What were you trying to predict here? Oh, I see.
predict means does this other parts actually cause some kind of influence on hotel occupancy rate? This whole part, those whole research is about that, and according to those variables of growth rate, this is about it, and it, comparing to last year, it has almost a similar or same frequency tendency to growth, and with this and this table and like a program results, I just make conclusions that those whole data variables has also high influential on the results of the occupancy rates. I just wanted more data about before and how this Philadelphia hotel managing strategies, but it might be too difficult to make research itself, so I just skipped it. That's all for my lecture.
Thank you. Okay, so, next person. So let's try and keep it to 10, not more than 10 minutes, because we don't have that much.
Okay. Huh?
Oh, okay. Hello everyone. So I made a project about the same Philadelphia hotel occupancy rate, and so I will say that I tried to, basically I'm trying to predict occupancy, and I will just start with the results to make it easier to understand what kind of results we got. So for the results, I looked at the literature, and it seems like the literature had the answer. And is it too loud? So in literature, so basically the results that I got were, I tested it once, then it looked like I got the accuracy rate of 0, and then changed something, I got about 45. And all in all, it wasn't as good as we wanted to be. And in the literature review, I found out that web traffic is very useful for predicting occupancy rates. And so it looks like the answer for perhaps the next project, or if I cannot find the data, well, it could just be a tentative solution to find the data for web traffic. So what kind of web traffic? I would say site clicks, how many clicks on which kind of links there are, and also how many people visit some certain tourism websites or reservation websites or blogs about the tourism destinations. And so this article talked about some kind of marketing organizations that have lots of data available, and they have data on web traffic too, and they are pretty much the only place to get data from. And so in here they got some data, and they used these kind of models, MAP and all these models, but these are not the ones that I have used. So why did I get the first result to be near zero? Well, first of all, we predicted occupancy rate from supply, and after looking at this in here, we found out that many are very correlated in here, many variables, and so is occupancy and supply. And so we don't want very correlated results. And therefore, I like the occupancy rate a little bit, and got different results. And so after it was about 45. I don't have a picture here. So I tested first with linear regression, and after changing it, some others, and it seems that neural network was the best one for predicting occupancy from past occupancy. So I lagged occupancy and predicted occupancy based on occupancy.
How much lag did you do?
Only one row.
1 day.
Yes. And so after that it got about 45, but still like I thought that it isn't like useful enough, and the literature review suggested that we use web traffic, and these are some graphs about how they looked at the correlation when using the web traffic data. So these are graphs of cross correlations, and these are the graphs for web traffic numbers. Not, for example, numbers of visitors and rooms of web visitors, rooms sold, occupancy rate. So based on the online data that they have gotten from those marketing organizations, they could predict at least something based on these models, and some models were more useful than others. And also we found out that neural network is more useful in predicting occupancy from occupancy than some other types of models like linear regression. So the point is, in this case, the article also tells us that some models are better from some things than other things. And what I also understood by making this project was the same thing, that sometimes we have to test the models and find out which models work the best for what we are trying to predict.
Okay, I have two things. One is in our data, in our art class, we're going to study this ARIMA models. We're going to do that in the economic data section. So we're going to do that in the art class. And also, we might be able to get this web traffic data from the same company that gave us the occupancy data. So I'll check with them and see if they can give us any data like that for the that'll be interesting. Okay, sorry.
That would be very useful, yes. So if we could find the data, I don't have any basis for my prediction, but I would predict that the rate of accuracy would go up from 45 to at least 60 if we could find some web traffic data. And the way I would use that web traffic data is look at those months of the, for example, let's suppose that somebody wants to plan a trip in 3 months. So today he's gonna go to some tourism websites or couch surfing, perhaps. Okay, maybe on couch surfing you can also meet people, so it doesn't exclude staying in a hotel. And there are also tourism forums, blogs, YouTube videos even. I don't know if we can get video about traffic of YouTube videos, but I expect the web traffic to increase a few months before lots of people make the trip. So they plan in advance. I personally would, a trip far away, I would plan it about 3 months in advance. And if it's like, for example, inside of Japan, it would be like 2 to 4 weeks, I guess. So we could use that kind of data isolated. And also another thing is that the reason why predicting occupancy rates based on occupancy rates is a good idea is because the days that are near each other are more similar in information. It's like, for example, if there are holidays, then I would expect the occupancy rates to gradually increase, not like shoot up. Or, for example, if it's like Christmas holidays, then like by this, during the start of the Christmas holidays, it would start slow and then like maybe go up. For example, 23rd is a bit smaller than 24th, December is bigger, and maybe New Year is the biggest occupancy rate. So that is why I think predicting occupancy rates based on past occupancy rates is useful. I think I'm running out of
You only
time.
did one day lag, right?
Yes.
You could have done 2 or 3, 4, 5, 6, whatever.
Yeah, what is one?
I mean,
Yeah, another way is to search for the days of the week. Even though we don't know which is Sunday or Monday, we still have like consecutive days. So we could put like group them into 7 groups and like. So.
what do you mean we don't know what's Sunday or Monday? What's that?
Because there are like days 1, 2, 3, 4, 5 in the data file. So we might not be exactly sure about which days are Mondays or Sundays.
You could make if you wanted to do that, you could make remember I think we talked about, dummy variables, or no, we didn't? Anyway, 0, 1 variables for day of the week. So you can have a 0, 1 variable, you could have 6 new variables that you could introduce into your data set. You could have a Monday, Tuesday, Wednesday, Thursday, Friday, Saturday. You only need, if you have 7 days, you only need 6 variables. And Monday would be a 0, 1 variable. So if it was Monday, it would be 1, and if it wasn't Monday, it would be 0. And then you have a Tuesday variable, and that would be 0, 1 also. And that way, you could include the day of the week as part of your data set. Anyway, I can show you that later, but okay.
So I guess it has passed already 11 minutes, so I'm going to end the presentation. Thank you for listening.
Okay, who's third? Who's third?
So So basically, I'm going to use the historical weather data I get from this website to predict the demand of the hotel rooms in Philadelphia, PA. And as you can see here is the raw data I get from this website. So it has like 12 attributes, and some of them are numeric, and some of them are not numeric. So I will just use those numeric data and get rid of those nominal ones. And I did two days lag, and so it's like, because I think like when people make the decision, normally they check the data maybe 2 days ahead. That's probably one general presumption here. So and here is the graph I did, like, because the demand, like, here the demand is normally 2 days ahead, and then 2 days later probably is very closely related. So I think it would be a good idea to see the correlationship here as well. So I add this variable here to predict the demand.
Oh, does that say 2L at the end?
Yeah. So
2 days lag.
2 days lag, yes. So the next step I'm going to take is examining the linearity between these variables, because sometimes it is possible that, as you can see here, that if some variables are highly correlated, so they will probably affect our conclusion towards the individual predictor. In this case, is the demand. So I used Excel, and I found that, like, putting temperature and the doer, you can see the demand, the correlation is very high. So I get rid of this variable, the mean doer, and then I normalize the data, the demand. So it helps me. Probably you can get a better result if you normalize the data. And here is the function to do so. Yeah, that's the part of the data after all the pre-processing process. And you can see there are around 10 variables, input variables. And here is the predictor. And then the next step I'm going to take is to turn the numeric data predicted demand, like what's a numeric data, and I want to turn it into a nominal one. So I use the filter. Where is? Yeah, I use the filter discrete to turn the numeric data into a nominal one with 10 distincts. So here is the result I get, and you can see, if you visualize it, that's the thing you will get from Weka. So for the evaluation methods, basically I think I only know 2 of them. One is about, it's called neutral network. We learned that in classroom. And and the other one is called the J48. I will talk about that later. And if you use the train set, you can see, yeah, the result is here. So basically, it's like 42%. It is not very high. And then like if you use cross validation with like to test it again, it's even worse, like 19%. And you can also see the precision and recall here in the detailed, like in the detailed summary. So yeah, basically that's like here is the function to get the precision and recall. And then you can test the result, like the data set again by using the percentage split. So I do this test 3 times. Like at the first time I did it with like 20%. So it's like I get a result around 17%. And the second time I did like around 66%. So the result is about 16%. And the last time I did with 90%, then I get 17% or. And if you use J48, you can see even to process the data, you get a much better result, which around 75%. So I think it's you can see probably those, yeah. So it's quite high correlation here, and the correct result here you can see, yeah. So yeah, I just repeated the test again and again and try to find the best result.
Was that J48? Did you repeat the J48 several times?
Yes, yes.
But only one time you got a really good result?
If you use the training set and the supplied test set.
Supplied test set. So you didn't use a split?
I also used the split here. You can see here is.
But if you use the split, you don't get a good result.
Yeah. Which is something, yeah, I don't really know the.
So what does, you know what it means to use the supply set? What it means that you build the model with the entire data set, and then you test that on the entire data set. So that's kind of like, we don't really want to do that, right? Right, because it kind of like, it sounds like cheating, right? Like you're training the model and then testing it on the same data sets. That seems kind of not very useful, right? It doesn't, I haven't seen that kind of difference though, where you get 75 when you do it that way, but when you split, when you do it as split, you have training and testing separately, you get such a dramatic difference. But anyway, that's what we got. Okay, go ahead.
Yeah, but yeah. So I think one way one thing we can do to get a better result probably is to use the select attributes. So using this function, you can the Weka can help you. Yeah, find out the most correlated variables here, and also it would be even more convincing if I can get the raw data about historical weather forecast instead of the real historical weather data, because that's what people look at when they make the booking decisions of the hotel. Yeah, I think that's all about my project. Thanks for listening.
Okay, next video.
Hello guys, and basically my project is focusing on the dedicated data set of the hospitality industry happening in Dallas, Texas, and the main purpose is to look into the demand and occupancy rate, and to answer whether the higher demand on one seasons can result in higher rate in occupancy rate comparing to the other demand in other seasons. And so for the data set, the data set recorded daily ranging from the beginning of 2013 until the last day in May 2014. And there are some variables in the data like average daily rate, revenue per available room, supply, and demand. And before I start doing in Weka, so I have to do the pre-processing, which is to clean the unused data, and data cannot be read in Weka, normalizing the numeric numbers into a new column to make it the numbers in range of between 0 and 1. And the raw data will be converted into CSV file to work in Weka. In the data aggregations, because I want to group the months from the data into seasons. So I group from June to August is summer, September to November is autumn, December to February is winter, and March to May is spring. As according to the climate, I search on the climate website. You know, they divide the months like this way, and only the demand column and occupancy rate column is kept to do the analysis. And I also categorize these data sets into 10 different levels, which is from ABC to IJ. And in the testing models and evaluation method, because in order to perform the confusion matrix, so I have to convert the numeric values into the non-numeric by using the discretized filter in Weka and apply it to occupancy rate. And I will use the neural network and the tree J48 in this project. So for the first method is the neural network. I use two test mode, which is one is split, which is resolving very high, pretty high. High result is about 47% correct, with a precision of over 80%. And in the training data, I get even higher, which is the precision is more than 90%. And in the G48, I even get a higher results. So as you can see that the split train and the training data can get really high, nearly 100%, I think.
Can you I don't understand. First of all, you're trying to predict occupancy rate?
Try to the demand rate and the occupancy rate. The demand in different seasons can result in different rate in occupancy.
So you're using demand to predict occupancy?
Yes.
That's.
No wonder it's so high,
that's
right?
why. I'm so surprised.
Yeah, but you can't do that. I mean, because demand
They're correlated.
and occupancy are basically the same thing.
Yes, I know, but so I see some limitation in my project.
No,
That I have
it's okay, but I mean, right? We can't. That's like using it's like this. I want to predict what Sony's stock is going to be selling at today, and I want to predict what its price is in yen today, right? And I use the price of it in dollars today to predict what it is in yen. Obviously, it's going to be a perfect prediction, right? All I have to do is multiply by the conversion factor, and I know exactly what it is. It's sort of the same thing because those things are very closely tied. So, but on the other hand, I don't think it would work, but on the other hand, if you lagged it one day and you used the supply to predict the one day before supply to predict today's occupancy, that would be fine. But the same day is like using the price of Sony in yen to predict what the price is in dollars. All you have to do is multiply by a constant and you'll get the exact number, right? And that's sort of the situation with the other. But okay, go ahead.
Okay. So that was like there's some limit. First comment is pretty accurate because the relationships between these two variables are so high and they're really correlated. And the limitation is not like because I avoid analyzing some kind of other variables and doing the data lags. So it will maybe give more like better predictions. And for the future, what I think the data from the yes, the amount of web traffic volumes because even in the first idea of for my project is doing the web traffic volumes, but I cannot find that data, so I have to change it to this. So I hope I can do a project with the web traffic volumes if you can provide it for me. So this is my end of the presentation.
Okay, good. And the last person.
Can I download some file videos?
Yeah, sure.
We better open a
Oh, yeah.
Otherwise,
Otherwise what?
the data will be saved in the website.
Okay. Which is better, Dropbox or MediaFire?
Dropbox. Why would we for Google Drive?
What? How about MediaFire? Is that any good? No?
It's-
Have you tried before?
It doesn't keep changing. It just stay the same.
What?
It just stay the same like for the how many years and
What do you mean?
I mean like it doesn't have any like effective changes like because it keep the same way of like working like people is not working up that way anymore like
Oh.
Because one is a cloud, the other one is just a file that upload download system.
MediaFire has some kind of cloud because they have like software in on computer, Steam folder, upload. But it's not really
But I think for like about $25 a year, you can have 1 terabyte of data on MediaFire.
But in Google Drive, you
What?
have to pay. In Google Drive, you have to pay $10 for 1 terabyte.
1 terabyte?
For
No,
$10.
$10?
I mean, every month.
$10 per month, yeah. But this is $25 for the year, you get 1 terabyte. Oh, but how are we gonna get the sound? Do you need sound or no?
Oh, no, it's okay. Hello everyone. I'm going to share some.
Microphone.
Hello.
Hello everyone. I'm going to share some of my outcomes in project 1. So, okay, so about a data set. So I have 2 data sets. The first one is the hotel occupancy rate I get from the professors in percentage during a period from 2008 to May 2014. And the next one is social media sentiment data. This data is, okay, I will explain about this data. So there's a website called San Diego Readers.
San Diego.
Yeah, San Diego Readers. So this website is a local newspaper online, and it has news about, mostly about San Diego. So you can see on this, okay, this one, and it has many kind of like stories here, and you can even search here. For example, I search for tourism, and there will be many articles related to tourism keyword in this website. So. So I think I will use those articles as data for measuring for predicting the level of occupancy level of hotel in San Diego. And because this is a local newspaper, so it's kind of like has many news about San Diego. And if it has keywords about tourism or hotel or tourist, it will somehow affect the readers or the audience about like, okay, whether we should go to San Diego or not. That's my hypothesis. So how can I get this data? So I write a program to scrap all the data, and you can see on the screen. Yes, sir. Here, like, you can see like when I run a program, it will swap on the articles here. You can see the date, 2014 October 28th, and those articles has a specific keywords like tourism or tourist or hotel. So I scrap all the articles to my computers.
So can I ask you? So you took you went you did a search for tourism in that search box,
Yes.
basically, and you get different stories,
Yes.
and then
The software will get all the articles,
uh-huh.
go to each articles and download the contents and save as a text file.
And okay, and does it also check the date?
Yeah, it's check the date.
Uh-huh.
Yes.
And does it check the date by year or by month or?
By both year and month. So I will explain later. So you can see, I scrap all the articles they have from 2008 to 2014. So
does everybody know what he's talking about? You can build a web scraper, which will just download stuff from the web, and you can build it like in R. You can build it in lots of different languages, and then it will just go out and search a website or even many websites, and based on some criteria that you build into the software, it'll scrape it or download those stories, and then he's downloading them into text files. So you have, how many text files did you end up with?
I did for keyword hotel, tourism, and tourist. I think totally is like 1,000.
1,000 keyword files. Yeah.
But like the data I use for my report is just like 5,000. No, 500. So as you can see, like I will go to the folder and oh no, not tourist.
What language did you use to build this?
I use Ruby.
Which?
Ruby.
Ruby.
Yes, and you will see there's many text file here. So for example, like for the keyword tourism, we have about 100. Yes, so that's how the program works. So after I collect all the articles, so I use a library of Ruby language. It will, how to say, it will calculate the measures, the sentiment level of the articles. For example, like if you say today is amazing, it will have positive sentiment level. If you say like today is boring, it will have like negative sentiment level.
Can I ask, does it give just one number for each article, or?
It both give positive, negative, all the numbers, and 0 is neutral.
Right, so it's just a single number. It's not like, some programs will give you like, you know, positive, negative about, but it also gives like a measure of anger and a measure of surprise and a measure of, you know, different things, different other emotions. But
Yes, it just give me just one number. So so I have that numbers and the occupancy data in an Excel file. So you can see this column is about the date, and this column is occupancy rate I get from the professors, and this one is sentiment data I get from my program, and this is the sentiment data after I doing the normalization. So I have all the data like the biggest one is 1 and the lowest one will be 0. So I have 4 columns for doing my analysis. Moreover, I also like characterizing the occupancies to 5 or 6 level, A, B, C, D, F, and I do the same with this one. Okay, so let me move this column to here, and I use the chart, and I have this data on secondaries. So we have something like this. So the red one is the sentiment data, and the blue one is the real occupancy rate. So there are 2 observations I see on the graph. First one is the occupancy rate is kind of like, it has kind of patterns over years. Like it's high in about July or August, and it's very low about January or December. So my hypothesis is like this data changes according to time patterns, like a monthly time patterns, like this one. And if we look at the sentiment data, somehow it also like in many places, in many points, it had in many periods it also had the same trends like this one. This one go down, this one also go down, this one go down, 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 and it's the same. But like one more thing is if you look at the occupancy rate, when it's the lowest point in about January, This points like the lowest points like improve each year to here, from here to here. And if we look at the sentiment,
What's that called, by the way? What do we call that? The fact that, that it's increasing. So there's what they call seasonality to the data, right? It depends on the season, but there's also a trend. The trend is beyond the seasonality, there's a kind of increase, right? Is what he's saying. So it's called a trend, okay?
and I see one interesting thing is the sentiment data is also like it varies a lot, and the variance is like bigger as a trend in here, especially in here in this period. The sentiment data is very high compared to other data, and I think my hypothesis is somehow affects the magnitude, the degree in which the accuracy changes. So it will change the direction into a seasonal patterns, but like how big it changes, it will affect by the sentiment data. That's my hypothesis. So I will do some analysis with Weka to see if my hypothesis is right or wrong. So first is let's look at this graph. This is I use the time series forecast of Waker. So you go to the package and you choose to install the time series forecast. So this time series forecast is used to forecast data in time-wise, and it will calculate the seasonal factors. Seasonal factors like, for example, like in the previous presentation in winter, the time they have like for example in winter it will go up, and in summer it will go down. It's like it has seasonal factors. So this model will help us to know whether the data they have seasonal factor or not, and the result turned out really great. So if I use the neural network, the direction accuracy is 95%. So direction accuracy is go up or go down. So it turns out to be 95%, and the error is kind of low. So as you can see on the screen, this image, the blue line is the prediction, and the red line is the real data. So you can think it's really fit. And in this picture, the dot line is for the prediction for the next 2 years. And you can see it also have kind of same patterns with the old data. So I can see that my hypothesis that the data occupancy rate changes according to seasonal factors is acceptable. Okay, so let's see whether the social media data they have kind of effects with the occupancy rate. So as I explained before, I will characterize occupancy into 6 levels, A, B, C, E, F, and I characterize the sentiment level into 3 categories, A, B, C, and I use Weka to test it with random forest model. And if I use the whole data as a training set, I got like 98%.
What was your input and output variables?
Input is date and sentimental level.
Okay.
And output is occupancy level.
Okay.
And I got the result of 98% correct.
That's good, except one problem is you don't know. Again, it's kind of the same problem as before. You don't know the sentiment level. Yeah, I mean you have to do a lag of the sentiment, right? Otherwise, you know, if I know the sentiment is this now, I want to know how that's gonna affect occupancy tomorrow, right?
Yes,
Not today,
yes.
it's too late today, right?
Yes. Yes.
Yeah, I have put it in further research.
Yeah.
And if I do percentage split, about 50%, use 50% of training and 50% of for testing, I just got 52% like correctly classified instances. So it tells me that like the sentiment level, the occupancy rate is not wholly depends on the sentiment level. So it has other factors that affect the occupancy rate. And moreover, I think that like the sentiment level, for example, like if you read newspaper on how say on San Diego readers, for example, if I go to San Diego like on winters or on summer and I see it very beautiful, so I start to advertise on the website. So the website is not only for predicting the rate, but it's also reflect the rate. So that's why we can see some patterns, some similar patterns in here. So my future works is first is why I want to use sentiment level data as lab data, as professors recommended, and next I want to see if the sentiment level they have effects on the magnitude of changes. So for example, like I want to see if in 2006 at about July it will go up to the highest points, but it will go up here, or it will go up to here, or it will go up to here. I think that somehow depends on the social media data, and I will put it in my future research. And this is the end of my presentation. Thank you very much for listening.
Okay, so we have some interesting stuff there. And, but we don't have any great, we haven't gotten any great rates yet, right? Forecasting rates. I mean, somebody got 98%, but I'm not sure how we can use that or not. So we have to think about what's going to be useful, you know, like predicting supply or occupancy rate from demand is not that, from the same day demand is not that useful, I guess is what we can say. Right? Of course, you can do it, but it's not very useful. So we want to come up with something that's useful. So so some people have come up with some interesting variables to include, like the weather and the sentiment. Both of those are very good. And but it seems like neither of them is sufficient. We want to add, maybe we want to use a combination of weather and sentiment, and maybe some other stuff now. And some other people talked about doing literature review and finding that the web traffic is also apparently quite useful. So we'd like to get that in there as well. I don't know if we can get that, but I'm going to try and get that data. Thing is though, of course that'll be really interesting if it's true, but except that it's already been shown, so it's not new, right? But anyway, still, I think we should, if we can get it, we want to try it out. But what else is there? Anything else? Of course, the sentiment and the weather are good, and like you said, if we could get the weather report as opposed to the actual weather. And what I mean is, you know, if you look at the TV or whatever, and it says, you know, the weather in Fukuoka is going to be miserable tomorrow, then you might change your plans, right? And you won't go. But it might turn out that the weather wasn't miserable tomorrow, right? It might turn out that the weather was fine, but you already canceled your trip because of the weather report as compared to what actually the weather was, right? But the thing is, I looked around, I don't know if you guys can find it, but I looked around, I couldn't find that kind of data. You know, yeah.
I think that the actual weather doesn't have any meaning in predictions, because if we have the model and everything in place and we wanted to predict tomorrow's something, then we only have the report. So if we want to test something, we don't know the real weather until it happens.
Right. Yeah, that's what I said. Yeah, so I'd like to get the report, but I don't know where to get it. It's easy to get the weather data, the actual data, that's everywhere, you can get that everywhere. But to get the weather report data, I haven't seen it. Like historical weather report data. Of course I can get today's weather reports by looking on, you know, but I need a whole list from the past 3 or 4 years. I don't know where that is, or if it's available. It must be available, at least to the people that make the report, they have it. But I don't know if they'll give it to us. But anyway, that would be good. What else? What else might affect occupancy that we might look for?
For one thing, certain places are more sensitive to weather than weather conditions than others, I guess. The places where people go out a lot, or when they go out, they're outside for a long time as opposed to like walking the city and getting into buildings. So perhaps cities are less sensitive, or all kinds of like indoor places are less sensitive to weather conditions.
Right, that's right. So a lot of you did Philadelphia. I don't think Philadelphia's sensitive to weather, I think. I would think. It's not like they don't have a lot of indoor stuff there. But there's another city, there's a city, there's a professor here, Professor Pardo, and he's from Montreal. He told me that the whole city is underground. I mean, he said because the weather's so miserable there, that, they have like a whole underground world there. So that would be a perfect example of the fact that the weather doesn't exactly affect certain parts of it. But anyway, okay, what else?
Well, for example, if there are events like Olympic Games in Tokyo, then they might I don't know if it's useful in predictions, but maybe for adjusting results a bit, it might in the long term, if we calculate this, what is it called, the degree K, the constant, the curve. Yeah, slope. If we calculate the slope, then we could predict in which kind of a trend it goes in. So maybe if our model is like this, but the impact of Olympic Games in Tokyo goes like this, so maybe we could, I don't know, look at the sentiment of that and somehow find it out.
So it sounds like you're bringing in your Forex expertise into here.
No.
Well, you just mentioned the slope as having some, what did you say?
No, in Forex I don't do slopes.
Oh, no? Okay, no. Okay, I thought it was.
Is that some event is kind of if there is an event, then it has an impact on the results, but our normal model cannot reflect it. Actually, yes, indeed, in Forex, if there are news, then price goes crazy.
If there's news?
Yes,
right.
like central bank decisions, then
Right. Oh, yeah.
everything goes crazy.
Right.
So, in that sense, inflation reports might change the trend even. So, for example, Olympic Games in Tokyo are considered to be a big thing for Tokyo. So maybe if we could look at that, for example, some kind of event, not necessarily, even in Philadelphia, some kind of
Events, yeah, right. Okay, good. Okay, now that reminds me, I said I would tell you about dummy variables. So let me tell you that. So did anybody leave any data sets here? What's this? Does this belong to somebody? Or that's mine? That's yours. What is that? Okay, let me just say, let me just use your thing here. So suppose we're trying to predict occupancy, right? Let me just put that over here. Okay? And then somebody says, now this is monthly data, right? This is monthly data. Okay, so suppose I want to include the seasonality effect. Okay? So what I was saying with dummy variables is you can do that, you can add, so there are how many seasons? 4, right? So so dummy variables you only need 3. Okay, like this. You'll call this summer. Okay, call this fall. And call this winter. And that's all you'll need. Okay, for 4 seasons, 4 values, you need 3 dummy variables. So what you do is, so here's January. So what season is it? I mean, yeah, it's winter, right? So it's not summer, so that's 0. It's not fall, so, whoops. Okay, it's not summer, so that's 0. It's not fall, so that's 0. It is winter, so that's 1. Okay? Now, how about February? What's that? 0, 0, 1. How about March? What is March? Is March winter or spring? Spring? Okay, so how do I indicate that? 0, 0, 0. Okay? 0, 0, 0. Okay, how about April? Same. 0, 0, 0. Okay? How about May? I guess that's still spring, right? 0. And then June is what? Summer, right? So how do I indicate that? 1, 0, 0. Okay? So in this way you can indicate every... Okay, let me just do this. Is there some way I can do this easily, or do I have to type it all in? So this is, I guess I have to do that like that. And this is 0, 0. Guess I have to type this. Must be an easier way than typing it, right? September is what? 0, 1, 0. And then I can copy that, right? And then what? December is 0, 0, 1. And then what? I can copy that. Like that, right? Okay, now I can copy this over repeatedly. So starting at March and going to there. Right? Okay, now let's do regression for this. And we'll see if we can identify what the seasonality effect is. So, let's see, we got these NAs here. Why do you have NAs? Just happen to be nothing there. Okay, so let's just fake it for now. Okay, here's another way, by the way, to deal with missing values. So one way is to delete that row. Okay? Any other ways we might deal with it besides deleting it?
Copy another result or something like
which result might I copy?
The one that is one result that is close to might be this one on the left.
Like, just copy this one down, right? Yeah, you could do that, that's one way. Obviously, these are, we're just guessing. I mean, we're just, it's not perfect, but yeah, you can do that. Or you could actually do something like figure out what it was. This is December, so what was it last December? And maybe introduce the trend, and then figure out what it should be here, right? You could do lots of stuff like that. But let's just do it in the simplest way. I'm just trying to, what's that? Oh, it's a, oh.
Yeah, you need to type it.
Hmm?
I think you have to copy to the.
Oh no, that's not gonna work. Okay, I'll do it like this. I'm just gonna fill this in. I don't feel like doing it properly right now, just trying to make a different point, so. Okay, so suppose we have that, and then let's just get rid of this. And, okay, so let's suppose we're trying to predict occupancy. We're going to use these variables to predict occupancy, okay? So we're going to use these to predict this. Okay? So let's do it with, let's just do it with Excel, and let's just do it with regression. So we have to add in regression here. Where is it? Down. Where is it here? Oh, options, sorry. Okay, go to here, go to add-ins. Go to here, and here, here. And then you'll find under data, you have data analysis there. And we use regression. And we'll use these. To predict, oh, sorry, that was the wrong one. Use those for this. And this one is here. Okay, and you put labels there, and that's enough. Okay, so very high. Is that true? Super high. That's what you got, right? You got something really high also, right?
I
You-
didn't
you-
do the sentiment. That one I characterize it to normalize design.
Oh, right. Anyway, it's super high. Is that true? It's really strong. So sentiment is really strong. But again, I'd like to have sentiment one day before, say in this case, 1 month before. This is collected at the same time, which again is not that useful. But still, it's interesting that it's so strongly correlated. But also, let's check these. So we get this. So we get these here. So how do we interpret these now? Okay, let me explain how you interpret these. So it's basically like this. This is not, first I'll say it simply but not correctly, and then I'll adjust it to make it true, correct. So it's basically saying that summer has a power of 11. Like when it's summer, you get an increase of 11. So by the way, what are these numbers? Right here. This is occupancy. You get an increase of 11%. Okay? So summer brings about an increase of 11% in our data. Okay? And the fall brings about a decrease of 3%, and winter brings about a decrease of 9%. Okay? That's basically what it is. But I didn't say it perfectly correctly because it's an increase from the baseline. So what's the baseline? The baseline is the one that's not given here. So which one is not given here? Summer, fall, winter, so spring is not given. Okay? So the baseline is spring. That's, okay? When everything is, when these three are 0, right? When the value of summer, fall, and winter is 0, that implies spring, right? Right, remember? So this is plus 11% off of spring. This is minus 3% off of spring. This is minus 9% off of spring. So the base is the one that's not coded in here. Okay, you understand? That's how you work with dummy variables. These are called dummy variables. Okay? So whenever you have now season is what we're investigating here, right? The variable that we're investigating is the season, right? And season has how many values? I'm sorry, season is what kind of variable? Is it numeric or nominal? It's nominal, right? Right? So whenever you have a nominal variable and you want to include it in your study, this is the way you do it. So in this case, we are doing season, which has how many values? How many possible values? 4, right? So for any nominal variable, the way you include it is you count the number of possible values, and then you make that minus 1 dummy variables. So you take n minus 1 dummy variables, where n is the number of values that that variable can be. Does this make sense? Right? So n was what for this case? 0. No. N was 4. And the number of, how many values can season take in reality? Forget about our coding. How many seasons are there? 4, so that's n. N is 4, so how many variables do you need? N minus 1. 3, right? 4 minus 1, 3. Okay, so that's the way you code a nominal variable. You create n minus 1 dummy variables, where n is the number of possible values that that original variable can take. Okay, did I say that clearly? Okay, so that's how you do that. And what else? Okay, and by the way, sentiment is that, well, let's do one more thing just for fun. Let's try to lag the sentiment by 1. Okay, so let's do that. If we lag the sentiment by 1, what happens to our predictability? That's what I want to see. Okay, let's try it one more time. See what happens. Input range is here, and this one is, oh, no, I have none. No. I have NA again. Just it's still really strong. Really? Amazing. Is that true?
So like the sentiment is only contribute like very little.
Right. Oh, that's right. Thank you. That's right. The sentiment is. Right. Right. Yeah. In other words, he's saying that if we did it without the sentiment, we'd still get a high number. Oh. Right. That's because we should also lag. Well, yeah, right. So that's saying that maybe we need to lag the season as well. No, we don't need to lag the season. Right. No, we wouldn't need to lag the season because we certainly can. Yeah. Okay, anyway, it's still very high. But it's true that the sentiment is not contributing a lot to it. But anyway, okay, so we have some results here. And we also talked about how to code dummy variables. Okay? Okay. What time do we finish? Now? Or 4 o'clock? Now. Finish at 3:50 or 4? 3:50, okay. Okay, that's all for today. Next time we'll talk about decision trees, and I'll report back to you about whether we can get web traffic data or not. Okay? And then we'll have to think about whether we're going to continue. How many people would like to continue the same project for the final project versus work on new data? How many people have new data they would personally like to work on besides hotel data? Okay. Okay, so that's all for today. And I'll try to assign you some homework via Blackboard if I can, although I know you worked hard this last few days, so you might want to break. But if I can think of some good homework, I'll do it. Okay? By the way, I saw something here, just mention it to you. This is one of my favorite sites. It's called rbloggers.com. It's all about R. And look at this. What does this say? Or just this part here. Cutting continuous variables. So you saw that some of you guys used a method for cutting up a continuous variable. What continuous variable did you cut up? You cut up the occupancy rate. You discretized it, right? So this is another, maybe this, I haven't read this yet, but it might be interesting, calling subjective ways of cutting a continuous variable. Okay, so I'm not sure what it's about, but it might be interesting to check it out. Okay? Okay, that's all for today.